are having with us Honorable Dr. Muhammed Shah Miran, sir, as a speaker for second technical session. He is professor of the Department of Chemistry in University of Dhaka. He is fully dedicated to the innovation of physical science, especially on nanochemistry and chemistry of ionic liquids for more than 14 years. He has been awarded with mixed scholarship and JASO Research Fellowship from Japan for his research work. He has 38 peer-reviewed articles, one book chapter, and 55 conference abstracts published to his credit. He is working with many professional bodies as a member. He is reviewer of many national and international journals. He is recipient of many notable national and international awards. He has visited several countries for the research purposes. We are honored to have such an eminent personality with us today for the technical session. Now, I request respected Dr. Muhammad Shah Miran sir to enlighten us on the topic materials, past, present and future. Over to you, Dr. Miran sir.
Thank you very much for your nice introduction. Are you hearing me?
Yes, sir.
Okay, thank you very much. Actually, it's very nice. I could join this nice webinar from Bangladesh. Uh, so actually, I also prepared my presentation based on the participant as I hear from Dr. Gunnole. Most of the participants are students. So thank you. Now I am sharing my presentation. Uh, So can you permit actually for sharing my presentation? I would like to share, but it says host disable participant screen sharing.
Sean,
Yeah, Dancer, you're the host now. Please start sharing.
Can try now.
yeah,
Okay,
okay.
thank you very much. So today actually I am going to talk on materials, past, present and future. My previous presenter actually make it easy for me. He already explained background and history of materials very nicely. So I organized my presentation like at first I will give you some introduction about materials. Then I will show some example about smart and intelligent materials. Then I will show some research, not detail, from what we did in Bangladesh. Then I will show some future materials, and finally I will conclude my talk. So actually, already it is explained that materials are probably more deep-seated in our culture than most of us realize. So in every aspects of life, it's very materials are very important and playing major role. So already it's discussed. Actually, we have a familiar with the Stone Age, Bronze Age, Iron Age, Plastic Age, and Information Age. So it is known. Actually, I'm there are actually so many classification of materials. In the beginning it was like metal, ceramics, polymer and composite materials. These days we are familiar with advanced materials, biomaterials, smart and intelligent materials and nanomaterials. So it is very known what is nanomaterials and advanced materials that are utilized in high-tech applications. Biomaterials must be compatible with body tissue and non-toxic. And smart materials actually designed to mimic biological behavior. Materials that like biological systems respond to stimuli. So actually, among nanoparticle, nanocarbon, nanoclay material, nanocomposites are very famous. Among nanocarbon, already discussed by several speakers about nanocarbon and nanotube and the graphene. These are very interesting materials these days. Many people are working on it because it has several potential applications. So, and also these nanomaterials playing very vital role for environmental segment like for cleaner energy, better energy storage, and treatment of water in every segment actually. But this is not actually new. Gold nanoparticles in glass are reflected as red. Ancient stained glass makers knew if they put finely ground gold or silver in the glass, they would get beautiful colors. They used nano-sized gold and silver particles, optical properties changed with the nanoscale. So actually, so now we are calling it nanotechnology, but 100 years ago it was known as art. So red stained glass gets its color from nanoparticle of gold that are only 20 nanometers across. And orange glass gets its color from gold nanoparticles that are 80 nanometers across. So we can change the color by changing the size of the same materials. Here I am showing three specimens. Actually, uh, uh, these are made only by aluminum oxide. However, these three specimens shows three different optical properties. You can see left one is totally transparent, middle one translucent, and right one is opaque. uh, Left one is made by a single crystal, middle one by the polycrystalline materials, and right one, in addition to polycrystallinity, it has some 5% porous. So you can see by changing the methodology and process, we can make different materials with different properties, though the main ingredients are similar. So there are actually so many methodology process people are using to develop new materials as per their demand, as per application. So what is actually smart and intelligent materials? Smart responds to stimulus with one predictable action. Normal materials have limited responses. Smart materials have appropriate responses, but response is the same every time. An intelligent response to a stimulus with calculated response and different possible action. Here I will show some examples. As you are watching smartphone, actually we cannot our daily life without this one. And here, NB things are also said there are so many thermochromic materials. So we can change the color by grinding or changing the temperature. These days it's a fashion. We are giving gift like this type of thermochromic mug or each other because it can change the color due to the thermal effect. It's also very interesting. And another one, shape memory polymers are polymeric smart materials that have the ability to retain from deformed state to their original shape by an external stimulus such as temperature change. This is also think as a smart and intelligent material. And materials, there are so many materials. Materials also play a vital role in the pharmaceutical industry. These days, we are facing very hard time due to the COVID-19. So, researchers are all around the world are trying hard to find an effective vaccine for COVID-19. Actually, already maybe more than hundreds vaccine are in trial position. So we have to find out a suitable vaccine for sustainability of our human being and what we are passing now. And smart polymer materials also become very interesting. And one age also is called the age of plastic. This has there are so many multifunctional polymer, fluorescent probe, nanosphere, cells, antibody, and drugs, and also polymeric hydrogel, the three-dimensional network of cross-linked polymer chain. You can see here, due to the cross-linking exhibit excellent mechanical toughness. Hydrogels can contain 99% water and exhibit low friction similar to natural tissue and cartilage. You can see the left one, a double network hydrogel which contain 99% water but is very tough. In the middle one is a self-healing nanocomposite hydrogel, and right one even they change the color due to the structural color by changing pH mechanical, thermal, and electronic stimuli. There are so many potential applications of hydrogel, like for self-healing materials, artificial muscle, sensor and actuator, separation and purification, shape-changing fibers, microfluidic devices, viscosity modifiers, control release, and even feeling cartilage defects. And we can also control delivery of our drugs, wound dressing, and also plant growth, alternative to soil, and even it can be used as a contact lens. So there are so many potential applications of hydrogel. So actually people are continuously developing also materials which is very interesting for energy field. In like here I am showing oxidation reduction of dimethyl cell stake. We need to develop new polymeric materials, new electrode, and new catalyst materials which are alternative to the platinum. And fuel cell, we are using fuel cell in our even pocket. Single atomic layer of palladium on nanoparticles of silver, formic acid as a fuel. All can be operated in the room temperature. We are not using here no solvent, no pollutant, so it's environmentally friendly. So now actually I show some research, part of research what we did at materials chemistry research laboratory at Dhaka University. So we are actually using two medium. One is ionic liquid, another one is the microemulsion. Actually ionic liquids I'll show later. Very amazing liquid medium. It can be applied for diverse purposes. But here I will show some results about metal for the to control the morphology of metal oxide nanoparticle. Another one, microemulsion, can be also used as a nanoreactor for preparation of metal nanoparticles and ocean nanoparticles. Well, actually, what is ionic liquid? It contains entirely ions. It is very interesting because it has negligible volatility, high thermal stability, chemical stability, high ion conductivity. There are so many applications including fuel cell, and even it can be used as a designer solvent for manifold applications. So ionic liquids can be divided into two broad groups. One is aprotic ionic liquid, which is prepared by the transfer of alkyl group. Another one, protic ionic liquids, which is produced by the transfer of a proton from a Bronsted acid to the base. Actually, I did my PhD on protic ionic liquids to use as a fuel cell electrolyte. But today I am showing I will use in I am also doing research on this field. But today I am showing we use ionic liquid for the preparation of zinc oxide. Uh, Here you can see one same image when we didn't use ionic liquids. It shows the dendrimer shape of zinc oxide nanoparticles. But when you use ionic liquid as the medium, we got 3D star-like shape of zinc oxide nanoparticles. And in one case, you say 1D rod-like shape of zinc oxide nanoparticles. And this is due to the actually the possibility of the formation of strong hydrogen bonding network between the cation or anion of ionic liquids. So we can say metallic oxide nanoparticles with tunable size can be synthesized using ionic liquid. And the shape of the zinc oxide nanomaterials ranging from nanorod to dendritic structure could be featured using ionic liquid as a size controlling agent. So ionic liquid can be envisaged as a novel green synthetic route for the nanosynthesis. Another one is a microemulsion, which we use basically as a nanoreactor. It is an excellent media for synthesis and chemical reaction. So actually we use this material at first for single silver nanoparticles preparation and other zinc oxide preparation. Today I am going to show one interesting feature like partial nanoparticles, which is heterostructured particles encompassing a material coated with other materials. Here you can see this is the coated and another one is the shell. There are so many advantages of these materials like enhancement of the stability and dispersibility, multifunctionality in a single material, modification of the surface and control the release of the core material, enrichment of the surface area to the volume ratio. So there are also several types of porcelain nanomaterials. One is inorganic porcelain, other is polymeric porcelain nanoparticles, and organic inorganic hybrid porcelain nanoparticles. I am showing inorganic porcelain nanoparticles. We prepared actually iron coated gold iron gold coated iron nanoparticles and silver coated zinc oxide nanoparticles by using the uh, microemulsion as a nano reactor. Here I am showing all the steps how we prepared actually gold coated silver nanoparticles. At first we add boric chloride, then we add sodium borohydrate, then there, due to the reaction, actually gold particle reduce. Then due to the coalescence, you can see several gold particle is produced. Then we did the same experiment for silver and sodium borohydrate. Finally, silver particle was produced, and you can see the silver gold coated silver coated gold nanoparticle can be prepared. So this is the DLS measurement. You can see the size and color difference for gold nanoparticles and gold coated iron nanoparticles. And we, for the confirmation of these partial nanoparticles, we take scanning electron microscope by changing the color and contrast. And we have confirmed from this study how partial nanoparticle is formed from the dark region and the shadow region. Similarly, we did also same thing for the silver coated zinc oxide nanoparticles, and using the same technique, we have proved that here also we could successfully prepare it. And finally, we can say metallic nanoparticles with tunable size and antibacterial properties can be synthesized using water in oil microemulsion, and also an iron coated gold and silver coated zinc oxide porcelain nanoparticles can also be produced successfully from microemulsion based template synthesis. And another interesting part is the functional nanocomposite. This is one of the major component of materials. There are so many nanocrystalline nanomaterials. So one is the matrix, another one is the disperse medium. When this basically disperse medium is in nano size, then we call it nanocomposite. And matrix maybe can be polymer or carbon materials or even ceramic materials. One interesting composite is a structural composite because the laminar and sandwich nanocomposite becomes these days very interesting. So functional nanocomposite. I'd like to give one example. Maybe you know the ingredients of Boeing 787 Dreamliner. If you see the composition here, you can see
आम मिलता है ना उधर
50% composite, 50%
इसमें देखना ना ऑनलाइन में
ingredients
है
of Boeing
प्रोविजन रखा
787 Dreamliner contains 50% composite and only 20% aluminium, 15% titanium, steel 10%, and other. If you compare with this comparison with the Boeing 777, only 12% composites and 50% aluminium were used in Boeing 777. And if you are interested, you can see the different parts of the plane, what type of composite or materials are used. Basically, it's uh, carbon coated reinforced polymer matrix. So due to use of composite materials, this plane become lighter. So fuel efficiency become very high, and range flexibility enables carrier to profitably open new routes, as well as optimize fleet and network performance, and for their passengers an experience like none other in the air, with more comfort and less fatigue. So it's very interesting. We need to develop everyday new materials, new composites for our future application. So before showing some future materials, I'd like to say we need to uh, plan our research and design, change our mind, and we have to change by ourselves depending on the regulation. We all know about the industrial revolution. So we are now in the fourth industrial revolution. What is actually basically on autonomous decision making of cyber physical systems using machine learning through cloud technology. Actually, what we are doing today, we are facing pandemic due to the COVID-19, but we could able to organize this webinar from different countries for our students, for young scientists, and also for our learning through the Google Zoom. So it's an excellent application of food regulation. So we need to think, we need to design, we need to change ourselves to adjust with the food regulation. So here I will show some future materials what can be used. Like you can see doctors inside your body. So we and also even we can wear some smart clothing where we can monitor our health system, where I am arresting by cardiac or is there any problem inside my body, and self-healing structure, and even more powerful computer, and fighting climate change. This is also interesting. Though these days we are having very nice environment due to the actually lower use of vehicles and due to stop industries. So we are getting very nice environment. But in future, uh, even now, we need to design new materials for fighting climate change. And you can see future material in the left side. If a performer use such a nice clothing which can glow light automatically, and molecular robots can help researchers build targeted therapies and next generation industrial regulation, and also future architecture can be like this. We need to design our building and car and everyday life. Maybe after COVID-19, we have to start change our lifestyle to for sustainability of our life. And finally, I can say material scientists and material engineers have made significant advancements in construction, medicine, computer science, energy, transportation, consumer products, aviation industry, textiles, packaging, biomaterials for tissue engineering, composites and metals for aerospace, eco-materials for green technologies, genetically engineered molecules, and semiconductors for electronics, magnetic materials for information storage, processing, biomedicine and energy conversion, polymers for telecommunication, and solar energy. So finally, I'd like to acknowledge to Professor Dr. Mohammad Abu bin Hassan Shushan, who is the group leader of our research lab, and also Dr. Gurnule for invitation. And at last but not least, Professor Edith Singh, he is a great scientist of India, but he has a, I think, great wishes for our laboratory and lab member. If always, thank you very much for your kind attention.
Okay.
Thank you, sir.
Thank you, Miran sir, for guiding all of us with your highly precious knowledge. Now I would like to request participants, if they are having any questions, they can raise hands.
I'm going to ask one question, madam. Hello, madam.
Hello.
Hello, sir. Thank you very much for your presentation, sir. It is very, very interesting. So you have talked about inorganic core cell nanoparticles. Okay. In one of your talk, you have told that silver nanoparticle and gold nanoparticle they can form the core cell. Okay.
Yes.
So in the case of the silver nanoparticle, we have got the SPR around 400 to 470 nanometer, whereas in the case of gold nanoparticle, it always come around 520 nanometer. It can be easily detected with the help of UV spectrophotometer. Okay. So my question is, supposing if this silver and the gold nanoparticle are formed, how can you detect with the help of UV visual spectrophotometer, sir?
Thank you, sir. Actually, we use dynamic light scattering technique. So by using these techniques, we can measure the particle size even 2 to 3 nanometer. So in one slide, actually, I showed GLS measurement. So we could measure, we have actually particle size, even 6 nanometer of silver, and we also showed that size of our portion nanoparticle is around 20 nanometer. Actually, we use dynamic light scattering method for the determination of size. Thank you.
Okay. Thank you, sir. Thank you.
Okay, next question is from Dr. Revika Arora. Hello, Dr. Revika Arora.
Okay, ask the question.
Okay.
Okay, you are audible.
Dr. Revika Arora. Okay, so next question is from Mr. Sandeep Rane sir. Sandeep Rane sir. Sir, you can ask the question. Okay, next question is from Mr. Sudarshan sir. Sudarshan.
Yeah, speaking, madam.
Yes, sir, you can ask question.
Sir, can we say that silver colloids are used to preserve the eye contact lenses?
No. Actually, I said hydrogel. Polymer hydrogel can be used, not silver nanoparticles.
Sir, any other uses, sir? This gold soul and silver souls in day-to-day life?
Day-to-day life, actually, silver is using as an antibacterial agent. Antibacterial agent these days is very famous. And for gold nanoparticle, I saw actually from the ancient age it's using as an art. And also from even 1000 years ago, I found that actually in China, they use as a treatment of arthritis as a gold nanoparticle.
Thank you very much, sir. Thank you.
Thank you.
Okay, next question is from Dr. MZ Khan sir. Khan sir, you can ask the question.
Madam, keep it a last question now. No, time running out of time.
Okay, sir. Okay. So I think Khan sir is not there. Now I request other participants to send their query kindly on email ID. We will get back to you with answers. Okay. Now I request Dr. Kalpana Singh ma'am to propose vote of thanks for today's event. Over to you, Dr. Kalpana ma'am.
Thank you, Ketki. So some of this